Hello everyone and welcome back to Aromatherapy. So please excuse any noise. I have my big dog at the side of me and he's snoring away because he's fast asleep. But yes, this is the chart. Now, in the last lesson, if you remember, I drew the plant and put the healing properties, therapeutic properties coming from them, etc. This is exactly the same, only this is a charted way of doing it. The idea is you can screenshot however you want and use this chart for yourself. It will help. Do remember that if you have a medical condition or you are on medication, please seek your doctor's advice before using oils of any kind. If you are having any other holistic treatments, then please seek the medical professional's advice before going ahead with aromatherapy oils. But this chart's just for you and your benefit so that you can screenshot and you know what is what and how it will help. I'll show you the rest of the chart. Please feel free to keep this for your benefit. Can you hear him snoring? Snoring away. This was a more complex way of doing it, but it fits them all on and it's, it's all right there for people to use if you want to. My other dog's snoring now. There's two dogs snoring. This is a chart for your top, middle and base notes. Generally, when you first start, you will have one top note, one middle note, one base note, 30 ml of carrier oil. Now, such as clary sage, basil, sandalwood, rosemary and peppermint, always have just one drop. With the clary sage, try and do one drop to 35 ml. Now, obviously no oils are safe to ingest, so please do not. Oils for children at 1 drop to 30 ml of carrier oil is generally Roman chamomile and lavender. The only reason those are there for children is because they are classed as safe for children. However, I tend not to use so much on children, on the skin or the body, maybe in the room, in the area where they are. You can do such things as pop drops on cotton wool balls, and then you can pop it on the radiator. That works just as well because it releases the oil. You can put a couple of drops in an oil burner with some water. That works too, rather than on the actual skin. Now, as we continue into this next lesson, this will be for more advanced chemistry. So it's for people who understand chemistry and who want to take aromatherapy further, because being an aromatherapist, we have to understand the chemicals within them and how they work. We also have to understand the pathogens, etc. So if you're not interested in chemistry, then honestly, there's no point in even going ahead and watching the rest of this lesson, because that's what it's going to be. Now, if for some reason you can't use a base note and you're missing it, so you're thinking, well, what do I do then? Because there's no base note for this particular thing in which I want. You can add another middle note, one drop of another middle note, or you can simply just leave it be. The only reason we have the base, the middle and the top is for the balance. It's to balance the mixture, and it does help with the scent too, as long as we're picking the appropriate oils. It does seem to make a difference to the scent, but do not be alarmed if there is not a note in particular for this certain thing. That does not matter. I mean, when we put them in oil burners, we actually only generally use one drop of something anyway in an oil burner. It wouldn't be a top, middle and a base. It's only for if that's going in carrier oils that we do that. Anyway, guys, that's the charting for yourselves for you to keep. The rest of this lesson is chemistry. So if you do not like chemistry, then please do not watch any further. So if you are joining me for this chemistry part of aromatherapy, it's more in depth. Please excuse my dogs, they are snoring at the side of me because they're Sparkle. So I apologise for the snore noises or the snuffling noises, but yeah, he's laid on my knee, so I don't want to move him. Chemistry becomes important regarding constituents inside the oils. It becomes important for what we are treating, for what the chemical is for. Excuse me. And not only that, once you realise what these chemicals are and what they're for, you can actually recognise them in many other products along the way. So you'll have a better understanding all around. I always put this because it's important to seek medical advice with your doctor before using oils with medical condition, medication you are taking, and other herbal remedies, because to counteract, they can cause some real problems. So it's really important that you don't mix. So, as an aromatherapist, we are the end users of essential oils, but actually we still need to learn and understand the chemicals behind the oils. This is because these chemicals actually mimic certain hormones in the human body, and even as today, some of them we know nothing about and are still discovering new ones. The end user means we are the person that gets the product once it's complete and extracted, and we use it, but that does not mean we do not have to know what is in it, because we do. So atoms are the smallest units in any element, and molecules are the smallest units of a compound. These, when bonded, create hydrogen, the first major category of compounds with hydrogen and carbon only, classified as terpenes. Oxygenated compounds, the second major category of compounds containing hydrogen, carbon and oxygen. These are classified under the various chemical types: acids, alcohols, aldehydes, esters, ketones, lactones, oxides and phenols. They are not exclusive to just essential oils. So the main ones being carbon, carbon dioxide, C, and CO2 being the base material in all plant construction. Carbon is the element that we cannot do without. It's the heart of all we are and the materials around us. Essential oils are made up of carbon, hydrogen and oxygen, the building blocks of the universe. Terpenes. These contain less than the maximum number of hydrogen atoms and are unsaturated, based on the 5 carbon compounds in the Isoprene unit. 2 main types of terpenes are of interest to an aromatherapist. Monoterpenes, made up of 2 Isoprene units, so 10 carbon units, limonene in lemon, bergamot, orange and neroli, for example. Then we have the pinene found in eucalyptus and cypress. So an isoprene unit is made up of 5 carbon compounds. As you can see, This is how it's laid out chemically. This is what you would expect to see on, let's say you were looking at products and it decided to show you a chemical chart as such, and yes, that happens sometimes, then you know that it has 5 carbon compounds. Carbon chemistry doesn't just form branched chains, but also rings. The more chains that are joined together, the more likely a ring will form. Rings can form from 3 carbons, but usually they are comprised of 5 or 6 atoms. Aromatic rings also utilize oxygen, nitrogen, sulfur, and they are the basic molecular building blocks, and from these basic elements a vast array of compounds can be built. Monoterpenes are found in most essential oils, but they have no real odour of interest. They're quite volatile, plus readily oxidised, which means that they will go off quicker too, if not with the correct other substances. So this is how a limonene would be on a chart, a monoterpene limonene. You would see it as this compound. This is chemical. It's how it's dotted on the chemical scale. Sesquiterpenes are made up of 3 isoprene units, as they contain 15 carbons. There are less common chemical components of essential oils. They have a strong odour, so play an important part in the fragrance of essential oils. These include chamazulene in camomiles, bisboline in black pepper, and carafilene in lavender, clary sage and marjoram. These odours determine the fragrance. So remember, when you are looking at something and you see it says sesquiterpenes, you know that this is made up of 3 isoprene units containing 15 carbons, and it will more than likely have a lot to do with the fragrance. If we look at bisboline, which is right there, that's what it would look like on a chemically analysed chart. So acids, organic compounds, a rare component of essential oils. Now they are based on the carboxyl group and have the chemical grouping COOH. Acids have a low volatility rate. Common examples of acids found in essential oils include benzoic acid in benzoin oil and geranic acid in geranium. And that is how a benzoic acid would look on a chart. So if you do see COOH on anything that you buy, this is from the carboxyl group of acids, and they are not very volatile, so they have a low volatility rate. Alcohols in general, based on monoterpenes, they contain 10 carbon atoms. They also contain the chemical functional group OH, referred to as terpene. Now these are derivatives because they are classed on the basis of which type of terpene was involved in their production. 2 minutes, guys. Sorry. So, monotopenic alcohols, most common type of alcohol found in the essential oils. Examples include linalool, this is in rosewood, and geraniol in geranium. This is the linalool monotopenic alcohol. It has the OH compound there at the side, and where I've marked it red, there will not, so usually you would get the full shape, but in this there will not be a line there, it would be missing. So the sesquiterpenic alcohols, with them not being so common, we have the Santalol, found in sandalwood as well. I had to put that on because I'd not brought it up before. Aldehydes are organic compounds. They're common essential oil components based on carbonyl. They are the C equals O. They have a fruity fragrance on their own. Generally skin irritants and sensitizers. They are your usually your citrusy stuff. So your citronellol, found in citronella, or citral in lemongrass. That's how it looks chemically, the CH to OH. But if you saw a product that said aldehydes and you looked within it, it would tell you, you know, citral. If it's citral, then you know that it's just citrus. But at least now you have some idea on what to look for. Esters are very important constituents of essential oils. They're from the corresponding terpene alcohol and an organic acid. They're based on the carbonyl group COOH. The highest are produced from a full bloom flower or a mature plant or fruit. Bergamot, the fruit will convert linalool to linyl acetate when fully ripe. Linyl acetate is in clary sage and lavender, and geranyl acetate in sweet marjoram, and they would be the OCOCH3, and you can actually see that sometimes on products if you look. So phenols, this is a thymolphenol OH. They are aromatic and similar to alcohols, but phenols attach to a carbon aromatic ring. The OH makes the phenol molecule very, excuse me guys, reactive. So essential oils in this category are generally irritating to the skin. I apologise. I always get a very dry throat from this. From reading or doing anything like that, my throat was very dry. They're generally irritating to the skin when large amounts are present. So remember that in small amounts, they're probably not going to do anything bad, but if in large amounts, they can irritate. Thymol in thyme, cavacrol in thyme, and eugenol in clove, and cinnamon and black pepper also contains eugenol. Ketones, potentially toxic compounds, and are similar in structure to aldehydes, being based on the carbonyl group C equals O. French shown in fennel and camphor in rosemary. They are toxic, but in a way that you don't want to be ingesting the oils or using too much. So that is what a camphor ketone would look like on a chart. Sometimes they do have just the C equals O on a product, but sometimes they have the picture. It depends on the product and where you're getting it from. Oxides are chemical compounds rarely found in essential oils. They tend to be non-hazardous. The chemical structure as the oxygen atom in the molecule situated between two carbon atoms, which means it goes COC. So the cineol, in its most common form known as 1,8-cineol, is in eucalyptus. Now, eucalyptus is extremely dangerous and should never be ingested because it can kill. Please bear that in mind. That's why you tend not to find many in essential oils. It's in the eucalyptus, but yeah, it's non-hazardous. But putting that substance like that becomes hazardous. Lactones are mainly expressed oils. They have a subgroup called brocoumarins, which are known as photosensitizers. And there's also now this is bragtine, and it can be pronounced bragtine or bragtine. I've heard it pronounced both ways. And this is the chemical structure, what it would look like on a chemical chart. So at the end of that, the two most important points are that carbon is the heart of any essential oils, and essential oils are from living plants. Do remember this. The essential oils come from our living plants. They come from plant DNA. They are extracted in an incredible way, and without carbon there wouldn't be no life in the plant, etc. So in a way, plants work like we do. But those are the two most important points to remember. So now you can look at certain ingredients and understand those chemicals and know what they are about, hopefully. You do have to have some knowledge of chemistry firsthand, I think, before going into this, but some people can just pick it up like that. Others would need separate chemistry lessons, which I'm not doing at the moment, but thank you all the same for joining me. Hopefully next time we'll be able to get into some facts about some of the oils, and then I can actually show you the mixing and the using of oils if you like. The practical side will come into play soon. Thank you for watching, guys. Love and light, and blessed be.